Alright, so here we go with some of the practice tests. Number 8. Which element does X represent in the following expression? So remember, when you have something like this, it's always protons plus neutrons at the top, which is known as the mass number, and then down here is the atomic number. And so when you want to know what element it is, focus right in on here and find element number 18 on the periodic table. So that would be the element argon right here. If they asked you how many protons and neutrons there were, then the protons plus neutrons would equal 39, and you know that the protons would equal 18 because that's how many protons there are in argon. That's called the atomic number, which is in the upper left-hand corner of this periodic table that, of course, you get on the test. So B. Number 9. How many neutrons are in the element 25, magnesium? So you know that it's got 12 protons. The number of neutrons you don't know, and you know that it equals 25 because this number, as we just said, is what's called the mass number, and so 12 plus 13 is equal to 25. So letter D. Which of the following is an alkali earth metal? So remember, on the periodic table, these are the alkali metals, these are the alkali earth metals. Other ones that you need to know, these are halogens and these are noble gases right here. And remember, these are called the transition metals, all the way from 3 to 12. And so these are the alkali earth metals right here, and so you match up one of them with it, and I believe it's strontium right here. Number 11, which of the following are not transition metals? So transition metals, remember, are ones that are right here in the middle. Lead is outside that zone, so that would not be a transition metal. Calcium is outside that zone, so that would not be a transition metal. Sodium is outside that zone, and so is potassium right here. Which of the following does not occur as a, it does occur as a diatomic molecule. Remember, the diatomic molecules are Br, O, H, N, Cl, I, and F. They make a sneaky 7 on the periodic table, plus this one. That's why it's sneaky. So you've got to match those up and find out which one's not. And argon obviously is not. This one is not diatomic, but it says which one does occur, so that means all of these are diatomic. Alright, number 13 through, let's do 13 through maybe like 17 and a half on this video. And these are gram to mole molecule type conversions. So in this one, how many moles are contained in 30 grams? So 30 grams of the C3H6O. Multiply sign, put a line, put grams of C3H6O in a position where it's going to cancel. Moles is your new set of units. You're just doing this right here, going from grams to moles right here. Molar mass goes on the bottom, so you got to add up C3H6 and O on the periodic table, and you get 58. So divide those two, and you end up with 0.5172 moles to 4 significant figures, which you're given right here. Number 14. How many grams of CO2 are contained in 2 moles of CO2? So now we're going from moles to grams right here. So 2 moles CO2, multiply sign line, moles of CO2 right here, grams of CO2 right here. Add this up on the periodic table, that's 44 grams. So if I add it up, remember we made this number right here plus 2 of this number right here. So 12 plus 16 is 44. So that's 88 grams. Let's see, number 15, the mass percent of carbon in methane. So methane is CH4. So you want to know the part that's carbon. So find carbon on the periodic table. That, of course, is 12. Hydrogen each is 1. So when you're finding percent, remember it's always part divided by the whole thing times 100%. And so carbon here would be 12 divided by 12 plus 4, or 16, times 100%, and it ends up being 11.1% for number 15. 16, the mass of hydrogen in water. So water is H2O. Each hydrogen is worth 1, so that would be 2. Water adds up to 18 times 100%. So 2 divided by 18. Oh my gosh, I totally wrote down the wrong answer right here. This should be 75%. Sorry, 12 divided by 16. This is 11%. My apologies. Just copied the wrong one down there. And then let's do 17. How many moles of NH3 can be produced by the reaction with 4 moles of N2 with 6 moles of H2? And it says hint, limiting reactant. So step number 1, write the balanced chemical equation. That's done for us. Step number 2, convert to moles. That's done for us. So we have 4 moles of N2 and we have 6 moles of H2. And then to find out the limiter, remember we have to divide by the coefficient. And so for N2, it's 1. And for H2, it's 3. And then what we want to see is we want to see which one's the smallest. So this, of course, would end up being 4, and this would end up being 6 divided by 3 is 2. So this one limits. Now, go back to this amount and continue with step 3 and do 6 H2s, and now do the comparison to the product that we want, or the piece that we're interested in, which is NH3. So put NH3 up here, H2 in a position where it's going to cancel. For every 3 H2, there's 2 NH3. 6 times 2 is 12 divided by 3. I believe that is 4 moles. Of NH3 is your amount that's produced. Now, the last step would be to convert to the asked for units, and in this case they want moles of NH3, and so we're done with number 17. Let's see, number 17 and a half, one more stoichiometry type problem. How many moles of N2 are needed to react completely with 6 moles of H2? Read the reaction above. So step number 1, write the balanced chemical equation. That's done. Step number 2, convert to moles. So we have 6 moles of H2. Put a multiply sign, put a line, and then it says step 3, do the comparison. And so we need N2 is our new set of units, H2 in a position where it's going to cancel. For every 3 H2s, there's 1 N2. 6 divided by 1 divided by 3 is 2 moles of N2 that are needed to react. Back with more in the next video.